we have in our company, Schibsted, and Stian basically found a solution for solve this problem. He will explain basically his approach to solve this problem and everything. And well, basically, thank you for coming. Thank you also to Schibsted, who sponsor meetup and provide us with the good food and drinks and all that stuff. And I think we start.
Thank you. So first, I'm going to talk about what secret management is. Then I'm going to talk about some of the existing solutions before I go into the details of Schibsted's internal solution to the problem. So first, a few disclaimers. So the information given might be inaccurate and is not enough to create secure applications. Also, you should consult your lawyer when it comes to regulatory compliance. Okay. So what is secret management? We're talking about secret management in the cloud setting. So you have multiple applications that need to get access to things. And that might be a database or something. So the first type of secrets is getting access to a database or other types of services. It might be an external API or something. And usually the solution for this is IAM, Identity and Access Management. So that's a very broad solution. And usually if you're on the Amazon cloud, like we are at Schibsted right now, then Amazon themselves has a really good solution to this problem. But you might have also other needs. Maybe you want to distribute your private certificates. Then you might only need a public key infrastructure. Then you might have information that is regulated by the authorities, and you need very special solutions to comply with that. And often then you use some kind of hardware security module. But we're going to talk about the rest, the ones that doesn't fit in one of the previous categories. So it might be access to databases you don't control. It might be encryption keys. It could be for JSON web encryption. And again, private certificates. It could be user data, it could be config. So it might not be strictly confidential. But you might want to keep it secret. So if you look at this in another way, secret management is somewhere between identity and access management and key management. So key management is only concerned about the cryptographic keys and managing those. And you might use a key management solution to create a secret management solution. And furthermore, you might use a secret management solution to create an identity and access management solution. So it's sort of this nested, like you make more and more higher abstractions. So we have these secrets, tokens, database key, passwords, whatever. And we want the service owner to be able to deploy their services and to manage their secrets in an easy way, while the attacker cannot interfere with, they cannot see the secrets and they cannot alter the secrets so that you change into something else. So then we have secrecy and integrity. Okay, so there are quite a few players already doing this. So the big one obviously is Microsoft, which has their own solution for their cloud called Azure. So Key Vault we're going to look at in a minute. Hashicorp is the other big player with their Vault. And then there's a host of other big names that's doing some kind of solution to this problem. And as we shall see, there's like no one fits all solution right now. So instead of picking a winner. We're going to look at some of the differences, and then hopefully you will be in a position to make your own choice for what solution best fits your needs. So the landscapes looks something like this. So in the upper right corner, so let me just do the axis first. So in this quadrant we have secret, so secret management, not key management, which is on the right. And then above the line here we have online solutions. Yeah, you need to be have network of some kind, and then offline, which you can do locally. So let's go through this. So both the big two I talked about, Azure's Key Vault and Hashicorp's Vault, they kind of have both key management and secret management. Then there's quite many solutions using Amazon's key management service as the for key management, the crypto part, and then they have some kind of enrichment on their own. So I'm going to go into the features of Strongbox in a bit, and then there's a host of solutions from quite simple like CredStash to more comprehensive like Biscuit. Okay, so there's also some specialized key management services, secret management solutions for container running containers. So you have one for Kubernetes, you have OpenStack, and also for Marathon. And then there's two other solutions called Nox and Kivis, and they are much like the ones over here, but they don't depend on AWS KMS to work. Okay, so there's also a couple of other solutions which are quite, well, they're a little bit different, and they can use PGP as the backend and not only KMS. And then just for reference, if you would have password managers, like for your Google account or whatever, then you could use something like 1Password and LastPass, and they would fit over here in the figure. So if you're on Azure, you should definitely check out Microsoft's Key Vault. It's quite a comprehensive solution. When it comes to Hashicorp Vault, Vault is not only trying to tackle the secret management problem, but also the access management problem. So giving access to your own databases with refreshing the tokens, so you can have short-lived tokens. So if somebody steals the token, you know that it will only be valid for a very short time. So Hashicorp's Vault also tackle that type of problem. For some of the others, like CredStash, it's very simple. So the features you can expect is very narrow, while others have more features, but they might also be hard to set up and maintain. So I'm going to get back to that later when we talk about Strongbox, which is the solution I've been working on for the past 5 months. The goal here has been to create something that is as good or better than all of the solutions we just looked at and a few more. We're not quite there yet. It's in alpha testing internally. There's a few teams trying it out, and we might open source it at some point. We'll see. But we wanted to show you guys what we were working on before it's quite done. So let's look at the features. So we want it to be easier to use. So it's serverless. Okay, so the first of this is only on Amazon right now. So it's serverless in the sense that you will install it typically using Homebrew, for instance, and then you get the command line. I'm going to do a demo in a bit, and then you're just ready to go. Like there's no configuration, there's no service to run, and it works with having multiple teams and multiple accounts, which is the case of Schibsted. So there's a GUI and a CLI that you can manage the secrets with. And there's a SDK for doing integrations. So it could be simple stuff like reading secrets or creating more advanced solutions. And then we also have an arcade integration. At Schibsted, we're using a lot of Netflix tools, such as Spinnaker and Eureka, and also arcades. So we wanted to have an arcades integration. So we wanted the security model to be as good or better as the existing ones. So most of the solutions only encrypt the secret, but we also wanted to encrypt the metadata, well, at least some of the metadata that relates to the secret, so that that's not visible. And we do that by encrypting it and also use padding. So padding is just to not being able to see, get any information from the encrypted blob by looking at the length of the blob. Yeah, and we also wanted there to be no configuration. So you just use the defaults and you're good. So we have quite a lot of features. These ones seem fairly basic, but you'd be surprised how few of the solutions are just shown that has all of this. So we have versioning, so you can have different versions of the secrets. You can set like states, this is enabled or disabled or compromised. You have not before, not after to indicate what period of time this thing should be accessed. And we support both having DynamoDB and local files as the backend, as well as letting the user have their own data in a field. Okay, so in some sense, this so we want to create a really good solution, but this is also a learning experience for us, so that we can know what to look for in other secrets managers to be able to make good decisions. And by owning the solution, we also have full freedom to integrate with whatever solutions we want. Okay, so this is the components. We have the SDK, which is used by both the CLI and the GUI, and the arcades integration. And while it's not done, we also have an experimental native client for Node.js. Okay, so the basic layout is like this. So you have the secret group manager that manages the secret groups. And the secret group is just a logical collection of secrets. So it's usually either your team's secrets or maybe a given service's secrets. So that's how you control access. So the services have access to a single secret group, and that secret group also have the resources, which are managed by you, so the user doesn't have to think about them. Okay, so let's look at how this is in practice. So this is our experimental GUI. It was written in a day, so it's a bit crude. So now I'm going to create a secrets group. I'm just going to call it team.projects. And we want this to be as smooth as possible and integrate with the AWS tools. So it's suggesting EU West 1 because that is my default region for my AWS CLI. So now it's going to allocate all the resources in AWS. And now we have our group. Okay, so let's create a secret in this group. Just going to call it my secret. And we have three options. We can either enter a value. So this might be your GitHub token or Datadog token or whatever. You can generate one random by using KMS. So KMS can generate up to 1024 bytes of data. Then you say how many bytes you want. Or you can select a file. So this might be useful if you have like a private certificate or something, and you want to store that as the secrets. So then we have the state, which is either enabled, disabled, or later you can set it to compromised to indicate that this key was leaked. And then maybe I want to have 1st of October this year and 1st of November next year as the window it can be used. And we have the option to add a comment here to maybe describe why we're creating a new secret or something. Okay, so then we have our secret. We have one version, and we have the data. And just like in 1Password, you have to actually say that I want to look at it, and then it decrypts. So it's encrypted until you want to show it. So the versioning is append only right now. So if we want to have new versions, we can append that. But we cannot delete versions. We can only delete the whole secret or the group. Okay, so this is how you would create secrets and to give access to your nodes in production or testing, whatever. You would attach a policy. So in Amazon, you have usually a role or something associated with your nodes. So now we're gonna assume that our nodes is in the secret manager test role, and here it gives me provides completion of actual roles in this account of Amazon. Let's see. And I want to add it as read-only. So now the secret manager test role has access to read my secrets. And the same for admin if you want that. Okay, so just one more feature I'm going to show in the GUI, which is the backup. So we're going to back up this secret group to file, and that's going to serialize it to a file on disk. So right now the secrets are in DynamoDB, but it can also be in a disk. And it's going to be encrypted, so you can check it into Git or whatever. So we do that. Then just to show you, I can do a restore on the file I just created. And this is only restoring the state, so not the whole secret group, only the secrets, and we're back. So if you want to read this from your application, you would add something like this to your code. So again, we have our secret group manager, and this thing is just going to pick up the default credentials in Amazon. You can override that just like any other AWS SDK. And then we do a get on the secret group. So we're in EU West 1, and it's called Team Project. Then we get our secrets group. And from that, we can, for instance, get latest active version, which is only going to retrieve the secrets if it's inside the not before, not after window we set. And then you can get the actual secret value. You also have some metadata here. Okay. So let's take a closer look at the architecture. So we have the secret group manager, and when you create a new group, it's going to create a secrets group and allocate the resources. So we have a store, which might be either DynamoDB or a file. We have an encryptor, which right now can only be AWS KMS. But in theory, it could be other things as well, such as Hashicorp's Vault Transit. But the one thing that's tightly coupled to AWS right now is the IAM policy management. So we create two roles, the admin role and the read-only role. And we create these so that the user don't have to worry about configuring them correctly. So they only need to attach to those roles, just like any other role in Amazon. Okay, so we have some work to do. We want to finish the beta, get more teams to try it internally. We want to improve the auditing. Right now we only get auditing through AWS's CloudTrail. And we don't have any tooling to make it easier to look through those logs. And we also want to support more languages. So we've done some experimentation with Node.js, but we use more languages in Schibsted, so we want better support for those. We wanted to make it cloud agnostic, but right now, before we have a cloud agnostic identity and access management solution, doing that is difficult. So a couple of notes on the underlying encryption. So we use the AWS Encryption SDK to not having to handle the crypto ourselves. So this figure is a simplified version of that. But what essentially happens in envelope encryption is that you, instead of just having one encryption key and encrypting your data with that, you ask for, like every time you have a new secret, you're asking for a new encryption key. That's called a key encryption key. Sorry. So in AWS KMS, you have a key encryption key. And that is what's used for encrypting the data encryption key, which you get one for each entry in like for one for each secret. So you ask for the data encryption key, and then you get the pair back from KMS. You get the data encryption key encrypted and unencrypted. And then you use the unencrypted version to encrypt your plain text, which is, in our case, both the secret and the metadata we want to store together with the secret. You encrypt that using the advanced encryption standard with the Gola counter mode, and you end up with the ciphertext. And you store the ciphertext along with the encrypted data encryption key and some metadata. And there's also some signature of the whole thing here to make sure that the integrity can be verified when you read it back later. Okay, so because of this two-layered encryption, so you have both the key encryption key and the data encryption key, and you have your own secrets. So if your secret, your GitHub token or whatever is compromised, you need to rotate that independently. Then you will create a new secret entry in Strongbox. But if you think Amazon's key management service is compromised, you would rotate that independently, and then you need to re-encrypt all of your stored secrets. So yeah, that's how it works when you do this two-layered envelope encryption. Okay, so to summarize, when you're looking for a secret management solution, you should look at how easy it is to integrate. So some of the solutions require you to actually write code before you can start using them. So there's one like you have to write Go code to implement the authentication before you can start using it. So that makes it more expensive to start using it. Some of them also only allow you to have a single access level, so across all your keys. That might not work if you have multiple services or multiple teams. There's also the maintenance cost of having to run a service to be able to provide secret management. And there's also the security model. So if you're going to expose all of your secrets in the company, like have them in one basket, so if the attacker gets access to that basket, they will have everything, or if you can compartmentalize it, having multiple accounts or other techniques. There's also this notion of encrypting only the secret or the secret and the metadata. So depending on your needs, that might be a thing, and also this having to configure it correctly. So in Amazon, there's three major ways of doing securing access to an instance, and we chose to only do one of them and auto-generate it so that the user don't have to think about it, while some of the other solutions leave it up to the end user to choose one. And depending on your users, you might not want to expose them to that. There's also history and auditing, so versioning of files, being able to comment if there's anything wrong with, like if they're compromised, or you want some extra information attached to the secret. And also auditing, and being able to look at the logs, maybe have anomaly detection in terms of somebody trying to steal all your secrets. And then there's availability, if this thing has a single point of failure, or if you can scale to a lot of traffic. And in our case, because we have this serverless architecture in Amazon, it's going to scale to whatever KMS and DynamoDB can scale to. Okay, questions? Yep.
Yeah, my question is, in the hypothetical case where you have a secret that might need to be used across several accounts, does that fit in that model? I mean, Strongbox, think about we have API, and account API or external provider that has to be used in 3 teams in all the environments that we or whatever.
Yep.
Would the team need to duplicate, replicate the secret and maintain different versions of the secret, or is there any solution?
So the question is if you in Strongbox can share secret between accounts, and the answer is yes. And the way it works is that you would use cross-account assume roles. So you would assume into the role that has the secrets and you can get access that way. Other questions?
If you store which policy that's great, so something like assume that today the policy of the company is delivery and insurance password.
Mm-hmm.
Good. Okay. Maybe this can vary from the time.
Mm-hmm.
It's okay. 2 years before, things change and you store in what context this secret is created. And the last time is accessed, so it's like also check for untouchable secrets for the past 2 years or something like that.
Mm-hmm.
Like most of the life cycle of secrets. Do you check kind of this?
So right now there's nothing built in to do that, but you do have when it was created and when it was modified, and by using CloudTrail you can see when it was accessed and who accessed it. And you also have the user data I talked about, so if you want to extend this to manage passwords for your company, then you could put that in the user data field and you manage that this was used with a certain type of policy. So I don't know if did that answer your question? No? Other questions? Oh?
The access to the secret, how can you know about when a secret is accessible? Because you, for instance, have this in a file, and then you have to put it in a file.
Yep.
So it have to be the SDK on this, or because if it's in a file, it will read the whole file, and only need to access one single secret.
Yep.
Something like this. So it's being serverless, and most of the logic is in the SDK.
Yes, yes.
So,
You still so the file, the local file, is going to be encrypted with KMS. So you still have to go online to actually decrypt the file.
yeah,
So
you encrypt the whole file.
So yeah, so it's actually 2 stages. So first you have to open the file, and that's one decryption, and then you get access to all of the metadata, and then you have to individually decrypt the secrets you want after that.
Yeah, but I mean, the SDK is who will at some point modify the access data.
Mm-hmm.
The access, I mean, it can be hijacked. I mean,
Yeah.
or in the
There's because it's encrypted, even some of the metadata, so you can check the integrity of the file, that it hasn't been changed. So if your client is read-only, they can't really change the data, but any admin service is going to be able to manipulate the metadata in a way that you can't discover. Other questions?
One more question.
Okay.
We are talking about also that we have different backends for storage. Right now it's files and MongoDB.
Yep.
Okay. I guess that it can also be storage backends outside Amazon, for instance.
Yep. So what we actually did is we created a key value interface. So just like Link for Microsoft, you have this high-level DSL to access key value stores. So what you need to do is just implement the interface for this key value store in whatever provider you have. So it's kind of neat, and we might open source that project as a separate thing. Yep.
I see that the security model is different from what other solutions offer, but not really that different.
Mm-hmm.
I was wondering if it would be cheaper to just contribute to those projects. So what did you take into account when deciding whether or not to start from scratch or contributing back to those projects?
Yeah, as I briefly mentioned earlier, the goal here is not to create a different project. So I mean, we'll still trying it out. It's in alpha, and personally, I have no problem doing a different project if that turns out to be a better solution. So it's back to that. We get a very deep understanding of the problem by doing it this way, and if the solution is better, and right now I think we have some interesting improvements, then it makes sense to do our own. But yes, it's of course already been quite an investment. So.
How can you convince your manager to let you do this?
So it's of course it's a very common problem. Like most teams have this problem, and solving it in a good way on a large scale is something that's important to Schibsted, and that's one of the benefits by working in a big company, is that you actually have time to look closely at problems like this. Yep.
As far as I understand, there's two profiles entities that can be admin or read-only.
Yep.
Would it make sense, or is it possible to create like a write-only entity? For example, if it is an application that just can write a secret, so that if that application is compromised, less than admin, so it just creates, and so somebody else can read.
I have to look closely at this, but right now I think the way it works with KMS and envelope encryption I talked about, it might not be possible to create a write-only role actually.
On Dynamo, maybe? Just
Yeah, on Dynamo definitely. Yeah.
that's another IAM.
Yeah. 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 Sorry. So you're totally correct. So you could of course create a different policy for Dynamo, but in KMS it's what I prefer is to have both the Dynamo permissions and the encryption permissions match, and the Dynamo is not a problem, but the KMS might be a problem in this case. But if you're happy with that, then of course it's fine. Yep.
Do you have plans to make it open source?
Sorry?
Do you have plans to make it open source?
I think so. So if it turns out how we would like, we're probably gonna try to open source it. But of course there's a lot of details there, and stuff I haven't talked about, which is there's a lot of tricky things. For instance, we use the JVM to do the secrets, and mostly that's fine. It's very productive, but things like clearing out the memory is virtually impossible. So there are still details in implementation we want to look closely at before we do that.
There's a trick that's put all the virtual machine and non-measurable memory. Just put them all.
Yeah. So
Is it true?
yeah. So the I guess the question then is like how much other stuff are you willing to do to make that happen versus just ease of use and ease of maintainability. So more questions? No? Okay. Thank you very much.
Okay. So guys, what happens when you don't have a proper secret management system in your company? What happens? Something like this, that at some point you will have a lot of secrets in your GitHub repos, Artifactory secrets, user passwords from databases, applications, certificates, tokens, and that kind of things. And at the end, you have all of this probably in a private repo, but at some point you make it public, or you even push it to the public GitHub at some point as well. And when you publish in a GitHub an Amazon credentials or Amazon credentials, what happens basically is that in 2 minutes you have some guy mining Bitcoins in your account. So what I did to try to fix this, it's to create basically a library that it's called secret, wrote this way. It's not cool. It's like in German. I think that in German secret it's wrote this way. And the idea of this library is basically to provide us some primitives to evaluate if there are secrets in some sources. I mean, not only repositories, but whatever source. I mean, files, Artifactory, repos, and everything, I mean. So the idea of secret is very simple. It's basically a library in which you have, it's wrote in Go, so it's wrote in Go. And basically you have to create you can create a secret context, a set of rules that can be loaded from path, from dir, from file. Those rules are basically very simple, are regular expressions, based on regular expressions. A little bit more complex because you have match and unmatched regular expressions. We will see later. Also, we can load objects. Right now, the library support 2 types of objects, directories and Git repositories. In directories, the secret will inspect all the files within the director. And with with the Git source, it will inspect all the commits. I mean, even if the file is not in the last commit, so not visible in the last commit, it will inspect in deep. And then, of course, I also support exceptions, because it's not easy to find secrets using regular expressions. There are a lot of false positives, and it's very easy to have false positives. So I added the feature to have also exceptions. Okay. And then it's very easy. Basically, calling inspect, it will launch as many Go routines as you want. In this case, 5 Go routines. And you just have to wait. It's, I think that it's the version I have published, it's synchronous, but I'm working to do it asynchronous, so you can do other things while it's making the inspection. Okay? And then you can collect the list of secrets using the list of secrets method. Rules. Okay, the rules. How are the rules defined? Very easy. It's basically you have two sets of regular expressions. The first one is match, and the second one is unmatch. Okay. So if a line in the object match with a line and doesn't match with any of those lines, it will be considered a secret. Okay. It's very simple. Very simple. And we will see some examples. Exceptions. Okay. Of course, exceptions are something that it's something we had to address when you are doing that, because there is a lot of exceptions. I mean, it's something that you need to fine-tune in your own code when you want to use it. For instance, what you can do to indicate that someone is an exception, it's a YAML file as well, like the rules file. It's also a YAML file, where you can put all these conditions. I mean, rule, object, line, and content. Okay, rule is the line. It's the rule that matches, that makes in this with all the conditions. Object is the object that also matches with this condition. Line, it's the line in which the secret is found, and content, it's the content basically that match the secret. So you don't have to use all of them. You can use only one of them. For instance, one line. If you indicate that in the file. In a specific file, the first line, it's not a secret. So even if he match with any rule, will not trigger the alarm in this case. And of course, if you have, for instance, a secret that you always use as an example, for example, I don't know, this is an password equal, this is an example, or something like this. If you always use the same as an example, you can create a rule, an exception with the content, with this content, and it will never be marked as a secret. Okay. Then this is a library. What I show is a library, but you can use it in other. The library by itself, it's not very useful. So you need to do some integrations, or you need to create other tooling using this library. And one of the things I created is Git secret. It's still in very early stage. I mean, it's something that there are some books already. I found one book this morning, for instance. I fixed it. But it's version 0.0.1. So it's very early ages. And I will show you more or less how it works. I will do a demo right now to show you how it works. Okay, can you see the screen? Yeah, more or less. It can be a little bit bigger. Okay, I have a repo here. Okay, I'm in a repo. Git status. In this case, there are some, this is a repo. Okay, it's very, basically with some files inside, some secrets in this case. I will show you one file, for instance, secret 7. This is a var that contains a secret. We have also in secret 8 this one. We have also 6, another one, and we have this one. So we have some secrets in some files, okay? Those, if basically Git secret, it's a module that it's integrated into Git, so you can use it as Git using Git secret, okay. Okay, it should, okay. This is basically the help. In this case, You can do config to manage the configuration on your settings of your Git secret in this repo or globally. You can apply everything you do in a repo, you can also do it globally. Okay? Rules, it's to manage the rules you want to enable to be verified in this repo. Check is basically to make the inspection. And hook is one of the last things I implemented. It's something that enables some hooks into the Git. So you can, for instance, enable a hook that verifies if a commit has a secret before doing the commit. Okay? So the commit, it's blocked. It's not done. Okay? I will show you some example. In this case, I need to do the git secret config init, okay, to create the initial configuration for this repo. Okay. Now with these secret rules, we can see all the rules I have right now. We have some rules. These are not very well-designed rules, are only examples I am using for basically to test it and all those things. But we have, for instance, one rule that works very good. Those two rules to detect Amazon keys in repos works very good because the Amazon tokens are very, very specific in length and char set. Okay? And there are also others like certificates, RSA, PGP or RSA, or even passwords. So the first thing we have to do is to enable the rules we want to have in this repo. Okay? It's basically with git secret rules enable. For instance, we are going to enable all the thirds. You can use wildcards here, okay, as you see. And I enabled all of this. And right now, we can make a check. Let's see if there is any of this check. Okay. In the check, you can basically. Oh, okay. When doing a check, you can choose in where you want to do the check. If you want to do in commits, in the last n commits, or if you want to do on the staged files that are already not committed. Okay, you can do both, even both together. I mean, we are going to see if there are some secrets on the last 10 commits in this case. Okay, and we see that there are a lot of secrets. Here we can see the file. Here we can see some metadata, like the commit in which the secret is, the object ID, which is an internal object ID used by Git, the rule that match it, and the content in this case. Okay, you can see that this file is the same because we enabled only the certificate stuff. It's the same file, but in different versions, in different commits. I mean, different versions of the commit. Okay, in this case. There's something I need to fix. I need to fix that because all the files are exactly the same. The unique ID is the same. So I need to consolidate this output somehow to make it more readable and better. But it's something that it's work in progress. Okay. Then what you probably want to do is to somehow to prevent to commit secrets. Because right now, if I do that, for instance, I create one in this case. I will. I think I have as example third. I copy this certificate here, okay, and I'm gonna make git add example third git commit add new file. Oh, in this case, I have the, okay. As you can see, I have the hook enabled. It's supposed to be disabled, but it's enabled because I did the test this morning, and I enabled it, and I didn't disable. But as you can see, the commit, it's not happening right now, because it phones secrets on the staged files in this case. Okay, I'm going to disable the hook. Wait a second. All these hook things, it's something that it's super new right now, so it's probably it's not working everything. I will try to disable the hook to see if it works. Now I can do the commit. Yeah, okay. With this, I disable the hooks. so the commit can be proceed. And if I enable again the hooks, and I'm trying, I don't know, example 2, git add example 2. And I'm trying to commit right now. It should fail. It failed. The commit cannot proceed. And that's something that prevents you from committing secrets in your own repos, okay? But of course, this is something that it's in your own. I mean, you have to use it. If you don't use it, at some point the repo will be on GitHub or even on. So there is another use case, which is basically to integrate this also with GitHub Enterprise, to continuously review all the repos within their GitHub Enterprise. For instance, we already have nothing done about this, but we are more or less thinking on this. Our first approach was, okay, we can use scheduled jobs to daily review all the repos and blah, blah, blah. But seems that the last version of GitHub Enterprise that was released some months ago or something like this has something that it's called server hooks, where you can trigger things from the server. Okay, it's something that we need to investigate to see what it's exactly server hooks. We don't know right now, but it's something that we can probably use if someone make a push. Then you can evaluate the commit, and I don't know if after or before the commit, the push already happened. So we need to investigate what these hooks allows us to do. Okay, and then another interesting thing, another important thing is that, of course, if there are a lot of false positives, and you need some way to manage this for your own repo. If you have a repo and you push the content to our GitHub Enterprise and you are getting a lot of notifications that are not real, at some point you will ignore all the notifications. So we need a way to indicate these false positives. So our idea, basically, our first idea is to have a secret YAML file in the repo itself. I mean, if you have this YAML file in the repo itself, when the secret is going to evaluate it, it will use it as an exception file. Okay? And this is basically what I wanted to present you, basically because we're in the context of secret management and all those things. And I did this short presentation, which is, well, it's done. And if you have any question or whatever, just shoot me.
The list of patterns,
Yeah? Yeah. I can show you. We can go, for instance, to GitHub. Right now, it's on the same repo in which I have the library. We have the rules. Okay. At some point, I will put it in a specific repo or something like this because it's something that has its own entity. But it's very simple. Here, for instance, the Amazon rules are very simple. Basically this. And I don't know, the certificates rules for there are this for generic, for PHP, for RSA. So it's very simple. It's very easy and very easy to create new ones.
Like a feature. Every time I see a reverse version, I think about Rock. I don't know if you're familiar with that.
No, what is Rock?
Rock, you know, is the solution that the creator of Logstash came up with in order to write and generalize or reuse the reverse version. You know, you look for Rock patterns. You will find some examples.
Okay.
Would be great in order to allow not only people, you know, if we all come up with a reverse version for, you know, machine code or whatever, we might have many, but if we can reuse them, then users can provide tools for
Sure. One of the things I was thinking about, because this rules stuff, it's something that it's you can do it as complex as you want. I mean, you can do at complexity or not. But for instance, I don't know if you are aware about Yara rules. Yara rules are basically something that it's commonly used in the malware. It's to detect malware, okay, and it's based on not only on regular expressions, but also it's a kind of so you can combine regular expression with ands, ors, and not only regular expressions, also other stuff. So it's like a kind of a meta language that has regular expressions and other things, and you combine them with ands, ors, and some logical operators. And this is something that it's one of the things that I was looking into as well to see if basically fits with my needs here. Okay, but I will take a look on how it's called. Grok. Grok.
Grok.
Okay, I will take a look.
And yours is
Yara. It's Yara. And you can see Yara rules, for instance, are rules to detect malware and indicators of compromise as well. Any other question, suggestion? Basically, this is open source. Basically it's in GitHub. 90% of this was code in my holidays in 1 week, so don't expect to be very. I mean, it's something that it's. I'm doing that for fun, so don't shoot me bullets. And contributions are welcome, of course. And that's all. More questions? So we have some food there, and beers, and Coke, water. We can go there then.